Hello everyone, welcome back to Bimbel Bilcen. In this video, we are going to learn about the discriminant, guys. So let's take a look at what is discriminant. But before that, let's consider these three quadratic equations first. So we have three quadratic equations and let's try to solve them using quadratic formula method. Yeah, you should remember the formula of quadratic formula is x equals to minus b plus minus square root of b square minus 4ac divided by 2a, where a is a coefficient of x squared, in this case is 1, b is coefficient of x, which is 2, and c is the constant without x, which is minus 8. Now, using this formula, we can solve this quadratic equation. So you can just plug in into the formula here. We have minus 2 plus minus square root of 4 minus 4 times minus 8, because a is 1, over 2. So here we have minus 2 plus minus square root of 36 over 2. Can simplify minus 2 plus minus 6 over 2. So we divide 2 for the two terms. We get minus 1 plus minus 3. So we have two value of x. The first one is minus 1 plus 3, which is 2. And the second one is minus 1 minus 3, which is minus 4. Here we have two distinct solutions, or we call it as two distinct real roots. So we call it as two distinct real roots. Because we have two value, distinct means that they are different, real means that they are real numbers, and roots is a solution to the quadratic equation. Now, using the same formula, let's solve the second one. A is 1, B is 6, and C is 9. So we get x equals to minus b minus 6 plus minus square root of b squared, so 6 squared, 36, minus 4 times 1 times 9 over 2a, which is 2. Now for this case, you get plus minus square root of 0. So it's just plus minus 0, yeah, which is doesn't really matter whether you take plus or minus because it will be with 0. So it turns out you get minus 6 plus minus 0 over 2, or minus 3 plus minus 0. So if we take the first one, the plus, you get x1 equals to minus 3. Or the second one, we get minus 3 as well. So they're basically the same, right? So we call it as one repeated real root. 1 because we only have one solution, which is minus 3. And then repeated, as you can see, whether we take plus or minus, we get same thing, and real root. Now, for the third one, if we apply the quadratic formula here, we have A is 1, B is 2, and C is 6. So plug into the quadratic formula, we have minus 2 plus minus square root of 4 minus 4 times 6 divided by 2a, or 2. For this case, you get square root of negative value, which is minus 20 over 2. Now, this one, we know that square root of negative number is not real. This is called imaginary number. So this is not real. So that means for this quadratic equation, they don't have real solution, or we call it no real root. Now, as you can see here, guys, we have three cases. The first one, two distinct real roots. The second one repeated real root. And the third one, no real roots. Yeah, no real roots. Now, if you look at the pattern here, these three depends on the value of inside the square root. If you pay attention, if the value of whatever inside the square root is positive, you get two distinct real roots. If the value inside the square root is 0, you get one repeated real root. And the third one, if the value inside the square root is negative, you get no real roots at all. So that means whatever inside the square root is very important. So if we take out the expression inside the square root, we call it as the discriminant, which is b squared minus 4ac. This is very important because this simple formula can tells us which category, how many real solution does the quadratic equation have. Yeah. So let's take a look at our summary here. If the discriminant, the symbol is a triangle like this. If the discriminant b squared minus 4ac is greater than 0 or positive, we discussed that the nature of roots is two distinct real roots. If the discriminant is 0, one repeated real root. If the discriminant is negative, inside the square root is negative, you have no real roots. Now, if we connect to the shape of a curve in a quadratic function, let's say we have quadratic function y equals to ax squared plus bx plus c, and we know that the shape of the curve depends on the value of a. Please remember, if the value of a is positive, its quadratic opens up. But if a is negative, it's quadratic facing down like this. Now, if you have two distinct real roots, yeah, means that the value of y is 0 because you want to solve the quadratic equation ax squared plus bx plus c equals to 0. Now, if you relate to the graph, you have two solutions. You have two distinct real roots. You have two value of x, x1 and x2. Yeah, same for the second one. You have two value of x. But if you have one repeated real roots, what happens with the graph? The graph only touches the x-axis. You only have one solution, which is one value of x. But if you have negative discriminant, it means that the curve either above x-axis or under x-axis without touching the x-axis depends on the coefficient of a. So that is the shape of the curve. Now, by using the idea of discriminant, we can also identify how many intersections does a line and a quadratic curve have. So, using the same idea, if you have a curve and a line, yeah, and then you want to find the value of x that satisfy these two equations or the intersection, yeah, want to find these two point of intersection or one point of intersection, or they don't intersect at all, or no solution, yeah, we can use discriminant, yeah. So for the 2 points of intersection, it means that the line cuts the curve at two distinct points. But if the line only touches the curve at one point, we call it as the line is a tangent to the curve. And you will learn about tangent line. A line, a straight line that touches a curve at one point only. But if the line does not intersect with the curve, means that no intersection at all. And how do we apply the idea of discriminant? So how to solve it? First, solve the equation simultaneously. Yeah, so you will get something called the intersection equation, and has to be in the quadratic because we combine quadratic with linear. And then we find the discriminant of the resulting equation. So let's say I have two functions. Fx is a quadratic, ax squared plus bx plus c. And the second one we have gx equals to a linear. Let's say we have mx plus maybe d because we already have c there. So how do we know whether the quadratic function and the line intersecting touches at one point only or they don't intersect at all. So first, you solve the equation simultaneously because we want to find the intersection if they have. So because they share the same value of y, so we can equate them here. Yeah. So we get ax squared plus bx plus c equals to mx plus d. And then we construct the quadratic equation from here. So we have ax squared plus bx minus mx plus c minus d equals to 0. Now, as you can see here, we get a new quadratic equation. We call it the intersection equation. So we have ax squared, and then we have plus b minus mx plus c minus d equals to 0. Now we have new quadratic equation and we can find a discriminant from here to decide whether they are intersecting or touching or they don't have intersection at all. And using the same idea, if you have discriminant more than 0, means that you have two distinct points of intersection. If the discriminant is equal to 0, you only have one point of intersection, or we call it the line is a tangent. If the discriminant is less than 0, no points of intersection at all. So these three conditions very useful to solve past paper that we are going to discuss after this. Okay, let's take a look at the first question, guys. A curve has equation y equals to kx squared plus 2x minus k, and a line has equation y equals to kx minus 2 where k is a constant. Find the set of value of k for which the line and the curve do not intersect. First, the keyword here, do not intersect. So you will expect the discriminant has to be less than 0. Second one, we have a curve and a line. So we can combine them to construct the intersection equation first. So let's equate them. We have kx squared plus 2x minus k equals to kx minus 2. From here, we can construct the intersection equation, the new quadratic. We have kx squared plus 2x minus kx minus k plus 2 equals to 0. So we factorize the x. So from here, we can find a is k, the coefficient of x squared, b is 2 minus k, and c is minus k plus 2. Now, because they don't intersect, so we use discriminant less than 0. So b squared minus 4ac has to be less than 0. Yeah. From here, we plug in the b, 2 minus k squared minus 4 times a is k, c is minus k plus 2. Now, okay, we expand this, we get 4 minus 4k plus k squared. And here we have minus 4k times minus k, you get plus 4k squared, and then minus 8k less than 0. So here we have 5k squared minus 12k plus 4 less than 0. Now, here we have a new quadratic in terms of k inequality. So first thing first, you can factorize. You need to find the critical value. So we have 5k squared become 5k and k. And then 4, we can have 2 times 2 here. And we get, we want to have minus 12. So minus 10 and minus 2 over here. So the critical values are 2 and 2 over 5. So this is 2 over 5. Sorry, this is 2 over 5. And this is 2. Now, because quadratic that we have, focus on quadratic in terms of k because we want to solve that. The value of a is positive. That means the curve will opens up. And we want less than. Less than means that we take part of a curve that is less than. As you can see, this part of a curve is in between 2 over 5 and 2. So the solution will be x in between 2 over 5 and 2. So this should be k. So this is the set of value of k such that the curve and the line do not intersect. Okay, guys, let's go to the next question. Here we have the equation of a curve, and the line is a tangent to the curve. So if you look at the keyword, guys, the keyword is tangent to the curve. Means that the line and the curve only touches at one point or one intersection. So the discriminant has to be equal to 0. So our goal is to find the value of k. So the first step, as usual, we need to construct the intersecting equation. So here we have 2k minus 3x squared minus kx minus k minus 2 equals to 3x minus 4. So here, we can simplify first. So we have 2k minus 3x squared minus kx minus 3x. This one become minus k plus 2 plus 4 equals to 0. And then as usual, we collect all of the terms, the x squared, and then we have plus minus k minus 3, the x, and the constant we have minus k plus 6 equals to 0. Apply the discriminant, and to the curve has to be equal to 0. So this is our a, this is our b, and this is our c. So b squared minus 4ac has to be equal to 0. So we have minus k minus 3 squared minus 4 times 2k minus 3. C is minus k plus 6 equals to 0. So we can simplify first. So here we have k squared plus 6k plus 9. This one, you can multiply the 4 first, becomes, or maybe the plus, the minus 4 aja ya, minus 4. So we get plus, plug in the minus 4, becomes minus 8k plus 12k. And then we expand, becomes k squared plus 6k plus 9. And we have plus 8k squared. And we have minus 48k minus 12k plus 72 equals to 0. We have a lot of things here. We can simplify. This becomes 9k squared minus 48k minus 12k minus 60 plus 6 become minus 54k plus 81 equals to 0. And luckily, we can simplify them by dividing all terms by 9. So we get k squared minus 6k plus 9 equals to 0. If we factorize, you will get k, and we have minus 3 and minus 3. So we only have one value of k for this case, which is k equals to 3. So that's the solution. Move on to the next question here. This one a little bit different. Yeah, we have another equation, the curve, and we have m there, and the line. Now, instead of finding the value of m before we want to find the value of k, right? Instead, for this type of question, we want to show that for all values of m, the line intersect the curve at two distinct points. So, how do we solve this? We are not trying to find the value of m, but instead we want to show that for any value of m that you choose, the line always intersect with the curve at two distinct points. So two distinct points, that's the keyword. The discriminant has to be greater than 0. Okay, so let's construct the intersection equation first. 2x squared plus 2mx plus m, I expanded, equals to 6x plus 4. Now, we can simplify first, becomes 2x squared plus 2mx minus 6x plus m minus 4 equals to 0. Okay, because we want to have two distinct points, so the discriminant b squared minus 4ac has to be greater than 0. So the b is the x coefficient, which is 2m minus 6 squared minus 4 times a is coefficient of x squared, 2, c is coefficient of, the constant, greater than 0. So we expand, guys. Here we have 4m squared minus 24m plus 36 minus 8m plus 32 greater than 0. Simplify, we get 4m squared minus 32m plus 68 greater than 0. And once again, luckily, we can divide all of them by 4. So we have m squared minus 8m plus 17 greater than 0. Now, for this case, guys, once again, we are not trying to find m. Yeah, because m can be any. But we want to show that all value of m, no matter what value of m that we put, this always holds true. But how do we show that this one always greater than 0, no matter what value of m that we put? Here's the thing, here's a trick. We can use completing the square. Why? I'll explain later. But let's do completing the square first. So m squared minus 8m plus 17. So we can complete the square. So we have m minus 4 squared minus 16 plus 17 greater than 0. So here we have m minus 4 squared plus 1 greater than 0. Now, let's use logic here. This is a square number, right? M minus 4 is a number, and then you square it. It's always either positive or 0. So this one always greater equals to 0. Yeah, but you add this value by 1. So before the minimum value is 0, now the minimum value is 1, which is always greater than 0. So that means for all values of m minus 4 squared always greater than 0. Then, or that means m minus 4 squared plus 1 always greater than 0. Before the minimum is 0, now it's 1. That means the line and the curve intersect at 2 points, or 2 distinct points. So no matter what value of m that you put here, it's always square. That means it's always greater or equal to 0, and then you add by 1. So the minimum before it was 0, now it's 1. So it's always greater than 0 in total. So that means any value of m that you put, the line intersect the curve always at 2 distinct points, because this always true, no matter what value of m that you put. Now, the last question here, it's the same question. Yeah, it's typical. And we have a curve and a line. And we want to show that, once again, we want to show that we don't want to find all value of m. We want to show that the curve and the line meet. So how do we show that the curve and the line meet? Be careful here. Meet. It means that either they have one intersection or two intersection. Whether they have one or two intersection, the line will meet. If they have two intersection, the discriminant has to be greater than 0. But it can be 1 as well, which is equal to 0. So we combine them, become discriminant greater or equal to 0, which means they have either 1 or 2 intersection. So let's combine them. Becomes 2x squared minus 3x plus 1 equals to kx plus k squared. Once again, we can construct the intersection equation 2x squared, and we have minus in the bracket 3 plus k x, and we have plus 1 minus k squared equals to 0. Now, apply the discriminant, but for this case has to be greater equals to 0. So b squared minus 4ac greater equals to 0. So b in this case is minus 3k squared, but we know that minus square is just positive. So we just write like this. Minus 4 times 2 times 1 minus k squared greater equals to 0. We simplify, becomes 9 plus 6k plus k squared minus 8 plus 8k squared greater equals to 0. So here we have 9k squared, and then we have plus 6k plus 1 greater equals to 0. Once again, how do we show that it's always greater equals to 0? Like before, we can apply continuous square method. So here we have 3k, or maybe easier if we just factorize them, and you will see why. We get 3k, 3k, and we have plus 1 and plus 1, right? So that means this is completely a perfect square. And we know that before, a square number always greater than 0. So for all value of k, 3k plus 1 square always greater equals to 0. That means the line and the curve meet. Meet. Yes. For all value of k. So this is all of the practice. Yeah, hopefully you will learn about discriminant well. Yeah, and see you in the next video. Thank you.